Yes, so this talk will be in English, so I'm sorry in advance for those who were hoping for a French talk to close this Hackfest. So first of all, thank you very much to everyone for taking the time out of your day to check out my talk. I think it's been amazing Hackfest so far. We've seen a lot of great talks. Both yesterday and today, and I know most of you must be really tired from playing the city hat, but hopefully it will be worth your while. So yes, today we'll be talking about threat modeling. This presentation is meant to be both like a high-level overview of what threat model is, what it's all about, how to do it, and also a quick start guide, so that hopefully, as a cybersecurity professional or as a developer, you will be able to start doing threat modeling and applying the concepts to your daily work as well. So before we start, who am I? So some context on my background. So my name is Sam. I'm an application security architect at Genetech. I've been working in tech for the better part of 10 years now, or just over 10 years actually. I have been working as a QA first, then a software developer, team lead, and then I moved on to application security. I have, as far as certifications go, I have my OSCP and OSWE. So I think it's definitely fair to say that I'm generally on the more offensive side of things. So both on the cloud and web application security field. So my passion is basically I love to make and break things and teach people how to do it. So I've been giving classes in different schools, universities, co-workers, a lot of different clubs as well. So you might definitely have seen me around a couple times. And the easiest way to reach out to me is through LinkedIn. So I do check it daily, and I would be more than happy to get a connection request from everyone that's attending this talk. So first thing first, to give some context to today's presentation, we will be answering 5 simple questions. So unfortunately, it's not going to be a very long talk. We're not going to be able to dive too deep into any of the concepts. But basically, my goal for today was to answer these 5 questions. So the first one would be what, second one, who, why, how, and when. So let's get right into it. So the first one is what. So this is the part where we define threat modeling, and I think it's really important before we go any further, before we start defining how to do it and so on and so forth, to make sure that we all have a good understanding of what it is and what it entails. So first off, I want to give a huge shout out to the Threat Modeling Manifesto people. So it's a group of 15 professionals with some of the industry leading experts, such as Adam Shostak, we have Chris Romeo, we have Alyssa Miller, we have a grand total of 15 people that have been working on that for a little while now, and it's based off of the Agile Manifesto, so it's meant to be super readable, super easy to understand. And what it does is basically define a bunch of key values and principles, which I will also be covering in this presentation. So hopefully by the time you come out of today's talk, you will have a good understanding of what it's all about. But in case you weren't so sure, do check it out. It is an amazing resource on that topic. Just let me make sure there's no questions so far. Perfect. Okay. So threat modeling, what is it? So basically, it's a repeatable process that establishes security requirements, identify and quantify threat and vulnerabilities, and determine and prioritize remediation methods. So that's a lot of words. It can seem a bit heavy, but basically what it boils down to is basically just having a recipe or a process that you can follow in order to identify threats and remediate and plan your remediation for them. So one of the key concepts of threat modeling is really just trying to identify what if shit hits the fan. So really often when we design software, when we develop software, we assume that everything is just going to go as planned and everything's gonna work the way it's meant to, and it's simply not true. So in the past couple of years, for a while now, really, we've been seeing things go awfully wrong with the threat landscape changing at lightning speed and basically being impossible to follow for most people. At this point, I think it's more than time that we realize that we're doing it wrong, and we have to start from scratch. So threat modeling is really just a new approach to software security, to application security, and a new way to identify and remediate threats. So in general, when talking about threat modeling, there's 4 main steps that we go through. So the first one would be the diagram, or identify what you are working on or what you will be working on. So in this case, the diagram is basically just the same type of data flow diagram that you would have in your architecture documents or as part of your software guidelines and just documentation, with the added touch of trust boundaries. So one of the important concepts here, and we're going to see like an example at the end of the presentation, but one of the main additions to this diagram is trust boundaries, where you identify basically different environments and different like networking and routes that you're going to have between some of your components. So once this is done, the second phase would be identifying threat. So this is the main phase of threat modeling. This is a phase where everyone basically sits down together and review the diagram to identify threats. So through questions, through open discussions, you start identifying what could go wrong and what would happen if it did go wrong. So you through that process, through those discussions, you usually come out with a bunch of threats or issues that you identify. And you can then move on to the third stage, which would be mitigate, or the mitigation stage, where this is the phase where you basically you open your tickets. So you decide, okay, so this is a high priority risk for us. It's really important that we fix it before the next release or before the next major, or you basically just determine what is important to you and what would cause the most damage if it was to go wrong, and basically just prioritize fixes. And then the last step in that process is to validate. So it is really important to make sure that the threat is properly mitigated in the case where you don't accept the risk and you really do want to patch it. And so this process can be done by developers, and can be done by QA, it can be done by security, and it's a very important stage. Because it really makes sure that you are leveraging your threat models to their full potential. So if you were to just generate the diagrams and then let them rot somewhere, or just make a list of threats and then never do anything with them, then the whole process would pretty much be pointless, right? So as far as handling threats go, there are basically 4 different ways that you can go around it. So the first one would be to mitigate. So mitigating is probably the most common one, and it's the one where you basically just patch the feature. So if you identify a threat, if you identify a risk, and you decide to mitigate it, you would basically just fix the issue in the code, or redesign if it's a design issue, and make sure that it's not possible to abuse it anymore. The second one would be to eliminate it. So in some cases, if there's like some really glaring design issues, if it would be either too costly or too complicated to completely eliminate the threat, then to completely mitigate the threat, then you can simply decide, okay, so you know what, this feature is just, it's not worth it. So like based on the income that it would generate for us, based on the demand from customers, or even maybe the current usage. So if you're able to monitor and see that not a lot of people are using a specific feature in your product, then you might just decide, you know what, let's just remove it altogether. And this is one completely valid way to handle the threats. The third one would be to transfer it. So in some cases, yes, it might be really hard to patch it in the code. Maybe the architecture issue is too big, and it's not possible to simply just go ahead and fix it. But you might decide, you know what, I can deploy a security control. I can deploy a firewall or a WAF, and just make sure that it's basically impossible to exploit it from the outside of the network, or from an unauthenticated attacker's point of view. And in some cases, it can work, because at the end of the day, your goal is definitely to understand risk and manage it, but you're never going to get to the point where you can completely eliminate it either. So in some cases, it might be acceptable to partially mitigate the risk. And you can also do that by transferring the risk over to your user, basically just telling them, hey, so like this one feature, if you activate it, there is a risk. Like if you disable rate limiting on this endpoint that you need to use, then there is a risk that someone is going to try to brute force it, but you need to accept that risk. And finally, as I just said, you can also accept the risk as a business. You can decide, okay, so there is a risk, but either because the impact is not big enough, or because it's it's very, very unlikely that it does get exploited. Then you can just say, okay, all right, so I'm going to keep track of this risk. I'm going to have still a ticket open or some sort of database where I can track the risk. But as it is right now, I think it's fine to keep it in my product, right? So once again, to take a different perspective, what threat modeling is. So first, it is a culture of finding and fixing security issues early and often. So if you're a developer, if you've worked with Agile in any fashion, you should be familiar with that type of approach. Break things fast and often, and it's basically the exact same thing here. So what you want to do is go through a somewhat formal security review very early in your process. Make sure that everyone gets a chance to basically sit down, give their input, discuss about the given system, and if there's any like glaring uh, architecture issues, then you can identify super early in the process so that you can remediate them before they ever make it to production. What it also is a chance for people with different skill sets and background to contribute to the security of a product. So this is a topic that I'm going to touch on a bit later as well, but basically this is a great opportunity for your security people, your QA people, developers, maybe stakeholders. Maybe you want to involve salespeople, maybe you want to involve project managers in that process and have them sit with everyone else and give their input on the threat model and see what comes out of it. Very often it's an hour or 2 hours that are very well spent. In the case of Genetech, we do a lot of threat modeling, and it's very frequent that we come out of one of these discussions with a head full of ideas and improvements that we can make to our products. And getting people with different skill sets involved is definitely a very good idea. It's also a great opportunity for developers, QA, and security to sit down together and have a discussion. So I think in the case of QA and developers, hopefully there's already good communication channels, but for security, and especially from security to QA, it's very frequent that there's little to no communication. So security just deploys tools and sometimes try to police what's going on, but don't have very good communication with the developers. And threat modeling is really an amazing way to somewhat like solve that problem. So it's a very good way for security and developers to sit down together, get a good common understanding of what the products are, what they do, and also identify some issues together. And finally, it's a systematic yet creative approach to shifting security left and identifying risk and issues. So I think shifting security left is a concept that everyone should be familiar with by this point. Basically, just making sure that the security team is not the only team or the only people that are the owners of the security in the business. And I think it's becoming more and more obvious that this is not an option, but rather just a requirement. It's a need. Like security should be everyone's responsibility. I also thought it was interesting to maybe define what threat modeling isn't. So threat modeling isn't a single person's job or responsibility. The security team cannot and should not be the sole owner of the threat model. So once again, this is something I'm gonna dive a bit deeper into in a couple of minutes, but basically it's just not realistic to have a single rock star, a single person in the business that is in charge of everything, all the threat models, all the analysis, patching the issues. It's just it doesn't make sense. It's not possible. So it's really everyone's job. Second, it's not an absolute science. So basically find what works best for you and your team. There's many ways to do it. There's a million different tools. There's a lot of ways that you can do it. And what works for another business might not work for yours. So the truth is security teams have a wildly different size based on the business, and especially in the case of small businesses, it's really likely that the security team might be one, maybe two people doing their best. And obviously, you can't have the same processes, and you can't have the same scope when you have this small team compared to when you have maybe several different product and application security teams and a much more scalable security effort as a company. Third, it's not a formal assessment of the security of a product. A threat model is not a penetration test, and I find it really important to stress that. So some people will assume that because they went through a threat modeling phase. They don't really need a penetration test, and vice versa. So maybe they will assume that because they had a pen test already, then maybe there's no point in doing threat modeling, because they see it as a cost rather than an investment, and they are completely different. And finally, it's not meant to be used as a way to judge or criticize anyone's work. So once again, I think anyone that's been a developer or that's worked on a product at some point remembers their first PR review, and they know how hard it can be to have someone else just criticize or review your work. And there's always this feeling that the security team is there to be the police and to tell them like what's wrong with their products and what's bad with what they're doing. And that's definitely not what this is about. This whole threat modeling thing is about the people. It's about making better product, but it's definitely not about pointing fingers and trying to judge the work that someone did. So moving on, who should be involved? So I guess I kind of spoiled this one, but basically I think at this point it's no surprise that my answer to this question is going to be everyone. So yes, security is everyone's job. The worst mistake you can make when threat modeling is to delegate everything to a single person or team. Everyone in the company has a different skill set, knowledge of different products, different interests. And by interest, I also mean the interest that they have as a professional. So either whether it's customers' requirements or features or lines of code as a dev, everyone is working on different objectives, and it just doesn't make any sense for a single person to be in charge of all of this work. So as a dev, as a developer, you usually have the best understanding of the technical implementation and requirements of the product. So obviously, and I was just talking about that, but in the case where you have a tiny security team, it's completely unrealistic to assume that your security people have a great understanding of every single product that you're working on, how your code works, all the tech you're using, and they might not even be up to date with it, and it's perfectly fine. It's already hard enough as a developer to stay up to date with all the new technology. So your role when doing threat modeling should really be to bring that to the table. Second, obviously, the data flow diagrams. So so this can be kind of a hot topic. I know some people believe that it should be the security team's responsibility to work on that. In my own opinion, I think that developers are the best people to do that. And at the once the company grows to a certain level of maturity, in a completely ideal world, the developers should be able to be the owners of that process. So start working on their threat models whenever there's more sensitive features or it's a new product. Reach out to the security team, work on them together, but still be the owners of the diagrams, the process, and be able to conduct threat modeling on smaller pieces of the applications or new features easily. Great. Okay. So moving on. So another thing that they should also be able to do is to be able to identify when you should threat model. So one thing that I get really often, because I have monthly meetings with the developers, and I try to stay in touch with the dev teams as much as possible. And one thing that I hear really often is, but it's heavy. It's a heavy process to always be updating our threat models, threat model every single feature. And this is 100% true. And it's also the reason why, as a developer, you should be able to identify, hey, so this new feature, it's not going this application is never going to run in a super sensitive environment. Even if it gets breached, there's no sensitive data. You pretty much can't pivot from it. It's just a single page application. It's going to be static. Then maybe there's no need for a threat model. And as a developer, it's perfectly fine to make that decision that you don't need it. As a QA, so as a test engineer or just a QA tester, so you have this weird understanding of the application and its quirks. You understand better than anyone else, really, how you can break the software, because you just through all the testing, all the checklists, all the work that you do, you have a really good understanding of the way the application works and the way that that a potential attacker could use the quirks and could use the bugs to their advantage. So by all means, QA should be involved in the threat modeling process. And they can also help to validate the mitigation controls. So in the case where developers do decide to patch out an issue or a problem, then QA could be able to first integrate the finding into their checklist. So maybe perform the same test that was just performed to make sure that the issue was fixed on different products or on different parts of the same product, and perhaps even identify new issues through that process, and also make sure that the fix is complete and it's fine, like it's adequate for the issue at hand. So obviously, it might not always be possible or realistic to expect QA testers to have a really good understanding of security. By all means, if as a tester or as a QA engineer you're interested in security, then please do get more training in cybersecurity. We really need you guys. But there's also a need for the security team to review some of the issues, and I think it's perfectly fine. Speaking of them, so the security folks, the security people, they bring the attacker mindset and the compliance aspect to the table. So maybe they don't have the best understanding of the application that's being worked on, or they don't have all the little bits and pieces of the context that it's going to evolve on, but they know how the attackers are going to try to break in, and they know what they're going to try to do once they get in. So once the developers have their data flows and they're ready to talk about their threat models, security people come in and they start talking about, okay, so this is how you could exploit the application. This is the kind of controls that would prevent me from doing so. Is that something that you guys have in place? Do you have proper authentication? Do you have, proper encryption for data at rest, data in transit? And maybe it's even questions that the developers are not going to be able to answer right away, and this is perfectly fine. Once again, the goal of threat modeling is really to have an open channel of communication and to get people involved and improve their product. So threat modeling doesn't end at the end of that meeting. It's not 1 hour or 2 hours of discussion and then that's it. Yes, there's mitigation, but there's also some concerns or some ideas that can come out of the threat modeling process. Finally, stakeholders. And when I say stakeholders, it's really a broad definition in this case. It's basically anything from management to customer support specialists. Because yes, customer support specialists can also be involved in the process. Oftentimes, they have a really good understanding of the way that customers are going to use the application, and maybe the way they deploy it, maybe some special requirements that they have. Product owners and management have a good understanding of overall the vision for the product, and also the requirements and the needs of their customers. So through having sometimes sales and sales in mind, and having direct communication with the customers, they're more aware of the way the application is going to be used and what the application where it's going. And this is really a vision that can bring a lot to the threat modeling process as well. So through that more user-focused and less technical vision of the product, you can also identify additional threats. And so some concern that some people might have is, okay, but what if they don't have the best technical understanding of the product? And I think this might not actually be an issue, but rather a strength. Oftentimes, we as security people and developers will have a tendency to focus on very technical aspect of the product while doing threat modeling. And having that different vision and the different questions that will come in can really help steer the discussion in a different direction, which might also be very productive. So by all means, don't discount people, don't discard people just because they don't have technical knowledge or background. Okay, so by now you should hopefully have a pretty good understanding of what threat modeling is, who should be involved, but now the question might be why. So if you're a manager, if you're a director, by this point you might be, okay, cool. So you're saying a lot of stuff. It sounds all good and wonderful, but so I already have a firewall, I already have an antivirus, I already have endpoint detection, I already have a WAF, I already have all these expensive tools, maybe a SaaS, DAST, SCA. So what now? Why do you want to add even more process to this whole thing? So this is why. As of 2021, 79% of all businesses push vulnerable code to their production environment. sometimes because they don't know it, sometimes because they need to meet a really tight deadlines, so they just push whatever they have basically, and sometimes because they assume that the issue is not bad enough. So sometimes even before, like without consulting their security team, just by themselves, they decide, okay, so you know what, this is not like a huge deal. Maybe we can just ship the POC and see how things go, and then they get pwned. Basically, it's just one more way to break into your network. So these are some numbers I thought were interesting as well. So according to IBM, as of 2021, the average data breach cost around $6.5 million US. So a lot more than 1 or 2 hours of work, even if you have large teams. There are around 30,000 websites getting hacked daily, according to TechJury, and according to them as well, 64% of companies worldwide have experienced at least one major attack. So I think if by this point you're still wondering, so why do I need to do all of this? This is exactly why. So this is like tools enough. The tools alone are not enough to stop attackers, and this is becoming more and more obvious. And if you rely on tools to protect your business, then you're bound to fail. So some of the reasons, once again, so we just highlighted what each person can bring to the table, and now I thought it was also interesting to highlight some of the, not necessarily shortcomings, but some of the things that each person might be lacking. So if there's no communication, if there's no exchange between the teams, choose something like threat modeling, then this is how you ship vulnerable code. So for developers, they often struggle to meet very tight deadlines and have little to no time to invest in improving the security of their product. So this is something that I hear time and time again. Yeah, so we would love to do threat modeling, we would love to do cybersecurity, but we just don't have time. Like we need to ship this new version by next Friday in 2 weeks. We don't have time, and then you get pwned, or we don't have time. Like right now we're going through the architecture phase of our new project. It's super cool, but we don't really have time to get security involved. Like we just really need to get this POC going, and then maybe in a couple of months time we'll be ready to present this to you guys. And really you can't blame the developers for that. I think it's one of the businesses realities that you need to ship your product, and security as a whole rarely ever, if ever, drives the business. And so there can be a tendency here not to prioritize security. Now then, as a security team, surely security should be the owners of security, right? That makes sense. So the issue with that way of thinking is first that they often represent a very small fraction of the entire development and engineering team. So I put 1 to 5%. I've worked in a lot of businesses, a lot of different contexts, and I think that's about a realistic number. So having 1 to 2 security people per 100 devs. So once again, for much larger businesses, there are definitely cases where there's much larger security teams as well, and there might be some security teams dedicated to a product team. But in most cases, for small, medium, and even large businesses, the security team is just way too small to keep up with all the new developments, all the new technology, all the new tech stack, and to scale up the efforts as well. So just spending so much time on their tools and training and best practices is already super hard and super time consuming. So it's just not realistic. And they also don't always have the authority to block a release or enforce a proper usage of the tooling or processes. So very often the security team will be able to roll out a new tool. For example, you can have something like a SAS, so a static analysis tool, or a DAST, so a dynamic analysis tool that you can roll out, that you can deliver to your product teams, and hope for the best. Basically, you just hope that they will use them, that they will leverage them to the best of their capabilities. But that's about where your authority as a security team ends. And this is something that stakeholders, this is something that devs can bring to the table. As a stakeholder, I think. So for stakeholders, it's a bit different, because stakeholders, as I said, have a very customer-focused vision of the product. They're client-oriented. They want to ship out new features and keep the business going. But I think they might have a fundamental misunderstanding of the value that cybersecurity team and cybersecurity as a whole can add to their product. So very often they will see that as a cost rather than an investment. So integrating security really early in your development process can be expensive. You can spend some dev time in that threat modeling review meeting or working on the diagrams, and this is time that they won't be spending on the actual product. And this is true, but it's also very important to understand that first, a lot of businesses are basically one attack or one breach away from going bankrupt, even if the business is going very good. Just one major attack can take you out of business or seriously harm your reputation or your revenues. And it's also the smartest thing to do to integrate it early into your development process. So once again, this is something I'm going to go over in a couple of minutes. I think one very big misunderstanding when it comes to security as well is that design flaws and code issues are the same thing, and they are definitely not. And one of the biggest difference is that code issues can be picked up by a tool. Something like a SAST will easily tell you, hey, so there's some cross-site scripting issues here, or there's a SQL injection there. But very often they won't be able to point out the design flaws. Something such as, hey, so maybe you should add authentication to this endpoint because it gives you admin access over another prod system. Maybe you should add encryption in transit between these two services because you're sending data over the public internet, and there is a chance that someone will try to do man in the middle or just eavesdrop. This is the kind of issues that will not be highlighted by tools, and that you can definitely identify through proper threat modeling and through just discussions and a good review of the architecture of your product. So it's really important to understand that there are definitely some great use case for tools, but you can't base all of your approach around tools, or else there are some things that you will be missing. So this is a quote from one of my previous manager. So he used to tell me compliance should be a byproduct of security and not the other way around. I think this is very elegant. This is very efficient at conveying the message that yes, PCI, ISO, SOC, NIST, whatever framework or certification that you're working on is important. So it can establish and certify a certain level of security for your business as a whole. But it's never going to be a proof that you're 100% secure. I think through the past couple of slides and through my message so far, it should be really obvious that security, well, like as an industry right now, we have to shift security left. Security has to be a people's problem, and we have to deal with it together. And it's not just something that we can achieve with tools or with compliance. So by all means, don't get flustered. I know there's probably some PCI or ISO folks out there, and you guys are super important. And this is by no means meant to be an insult or to say that it's not necessary. But you should be always aiming for security, and compliance should come with it. So in a world where your application is secure, you should be compliant by default or very close to it. Okay, so I've been talking now for 35 minutes. I've given you a lot of information on what threat modeling is and who should do it, and it's all cool and fun. And I think the one question that comes up the most often when I talk about threat modeling with our devs is basically how. So I have a good understanding of what it is, but now I want to start doing it, and I'm not sure. So for your diagrams, which should be your first step, there's many different options. There's the Microsoft threat modeling tool, TM7. This one is free, and it's great. There's also two different projects from OWASP. So there's ThreatDragon and there's PyTM, so threat modeling as code. So if I think this one is written in Python. So if you're familiar with Python, if you're comfortable with it, it's one way to generate your diagrams. And basically bring your own tool. This is not a sales pitch. This has nothing to do with a specific tool or a specific way of doing things. And once again, I really want to make it clear that you as a security professional or a developer have to find out what works best for you. And these are just some examples of what you can use. So how can I identify threats then? One very good starting point is Stride. So I'll be presenting that in a minute. But in case you're interested in other frameworks or other guides that you can use, there's so OWASP again has two very good projects. There's the ASVS, so the basically just the application security verifications. There's the security testing guides. So there's one for mobile, there's one for web. Just grab them and use that as a reference. There's the NIST. So NIST has a lot of guides, a lot of frameworks, a lot of documentation that you can use as a starting point. Also frameworks or standards. So maybe if you work in an environment that needs to be PCI compliant or GDPR compliant, you might want to take that into consideration when you're going through your threat model. So either from a security or devs perspective, just make sure that you're covering all the basics and you're compliant with it. So obviously, this is never going to be as thorough as an actual audit or certification process, but it might be a good time to take these into consideration. And it's also a good way to a good time to evaluate your existing security requirements, policies, and checklists. So maybe QA wants to bring their regular sweeps and checklists and see if just anything in there that could be relevant. Maybe you have a secure coding policy, either through ISO 27001 or just as a company, and you want to use that as a reference. This is great. This works. Or really just any document. It's not an absolute science. There's a lot of resources and a lot of ways that you can do that. Okay, so I did promise I was going to cover Stride. I find Stride to be very efficient, and it's an acronym that stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. So basically, for each component of the system, for each maybe trust boundary, you go through this list and you just try to define. Okay, so like if can I spoof the request? Like, can I pretend to be someone else, or can I bypass maybe the authorization mechanisms? Can I tamper with the request? Can I compromise repudiation? So is there any way that I can perform actions without them being logged or without the owner of the application being able to identify who performed them? And so on and so forth. So I think pretty much all of them are self-explanatory, and otherwise there's a lot of great documentation out there. But as a starting point for threat modeling, I think it's great. Okay, so maybe some more tips. So break more complex systems down into smaller pieces. So analysis paralysis is a huge thing when it comes to threat modeling, just trying to figure out, okay, so how do I get started? Is my threat model going to be like perfect? Is it going to be good enough? And I think it's a case of really just do it. Just start working on the diagrams. Just pick out like one small use case or one small subset of your system and start working on it, and the rest will come from there. As you gain more maturity, as you get more comfortable with threat modeling, I think it's going to be easier to like model your systems and figure out exactly what you should be threat modeling and how you should be doing it. And as a security team, you've also gained maturity as to the type of questions that you should ask and the type of threats that are likely to come out of a system when performing threat modeling. But you shouldn't be aiming for perfection. You should just be doing it. There's also make separate threat models to illustrate specific use cases and workflows. So this one is really interesting. Very often when you're working on your first threat model, you're going to start wondering, okay, so am I being clear on what exactly this system is doing, or like what information is being passed around, or exactly what is happening here? So you can totally have your main threat model and have your like some smaller ones on smaller subsets of the system and just go through this specific use case. So for example, say you want to model out your authentication process. So you would just have your user, your authentication gateway, your service, maybe a DB, and that's it. And then just map it out. Just go through the flow and perform threat model on this specific piece. If it's too small, maybe you can do 2 or 3 threat models in the same threat model review, and that's perfectly fine. But it really helps to like illustrate certain processes or what information is being passed around without making your main threat model too complicated. And finally, there is no such thing as a stupid question. So obviously this one is mostly for the review part of things. And so even if you feel like this is something that everyone knows, just ask. It's very likely that someone else will have the same question, and even if they don't, it's always a good opportunity for devs or for everyone involved, really, to make sure that they have a good understanding, first, of the system, and second, of what it really does. Because there's a lot of cases where people assume that things will work a certain way, and they might not, and there might be some vulnerabilities or some threats that are hidden in the way that they actually work, and maybe you might trigger a pen test or a more advanced review of a specific feature or code block as a result of what seems like a stupid question. So just ask. Next one, mitigate. So I think this one I've covered quite a bit already, but basically just this is the part where you open and assign tickets. So whether you're using Jira, Helpdesk, TFS, or a combination of all of those, or I don't know, Jenkins, this is the part where you open tickets and just work on stuff. So for this step, you can use the CVSS score, so estimated vulnerability ranking score, as well as the impact, the likelihood of it happening, and so on and so forth. You can have different criteria based on your own preferences, and basically just fix issues. And so the last one is validate. So once again, I think this is one that I've started to cover quite a bit, but as dev team gain more maturity, it should become easier for them to validate security fixes with confidence. So when you're a bit more junior, obviously your main focus is going to be programming. So just understanding your tech stack and understanding just what your code does and how to use different tools and so on and so forth. But as you get more senior and more mature with development, you might want to start branching out into other areas such as security, and be able to implement and validate security fixes by yourself. And QA is also a good resource for that. So obviously, security can also help validate security issues. In the case of like super tricky blind SQL injections leading to RCE, where devs might not have the proper tools to reproduce them or make sure that it can't be bypassed, then you can get the security team involved as well. Finally, when? So this is the last question. And so what I put there is also known as just do it. I think it should come to no surprise that do it early, do it often, and also measure twice, cut once. Basically, it's at the end of the day, it's not a cost, but rather a time saver. So if there's any like huge architecture issues that come out of a threat model review, first of all, great job. Second, it's much easier to fix them before the code has been written, before it's been shipped to production, and before people have started using it, than it is to do it maybe 4, 5, 6 years down the line, where people are used to it being like working a certain way, and you will get a lot more friction, a lot more resistance when you're trying to fix things. And in some cases, it might really save you. So in the case where exploitation might have leaked all of your customers' data, then picking up on it very early in the process is going to be super beneficial. So basically, sometimes when you could want to do it is when starting a new project, when designing a new feature. So there's one concept that is security relevant that can be taken into consideration as well. So basically, where is this going to be deployed? What kind of data is it going to handle? Is it going to handle PII, so personal identification information? Is it going to handle like super sensitive data? Is it going to have access to other production system that might be, or is it just a very small feature that can't possibly have an impact? When there's a significant change in scope and trust boundaries, for example, if you add new components to your system, or if you're shipping an old application to a new environment, just maybe threat model it to see what impact it could have. And now, like if you're not doing threat modeling yet, it's a great opportunity. It's a great time to get started, and don't aim for perfection. Basically, just do it. So I did intend to do a bit of a hands-on example. Unfortunately, we really won't have a lot of time today. So I just wanted to give you a very high-level overview of what this could look like. So basically, this is just a good old data flow diagram with the addition here of a trust boundary. So here we have Azure. So we're leveraging a bunch of services in Azure, so we can assume that it's on the same trust boundary. And on the left, we have the public internet. And one very common mistake that we see is that people assume that you can consider public internet or open networks as a single trust boundary. So in this case, it would be a mistake to identify the public internet as a trust boundary for the simple reason that you really have no control over what else could be running inside of this environment or inside of your public internet or your public group. So in this case, it would really only be true to say that the right part is a trust boundary, really. All right, then, key takeaways, really quick, because I see that we're about coming up on time. So there's basically 4 of them. First one would be that threat modeling is an awesome culture that will save you time and let you solve problems before they happen. I think this one doesn't really need any explanations. Shifting security left is the only way we will ever be able to face today's cybersecurity challenge. Security is everyone's job. You can't just delegate everything to your security team and hope for the best. We all need to talk together. We all need to work together as a dev, as a QA tester or engineer, as a security professional. Start small and work your way up from there. Analysis paralysis is real. And I think some threat model, even if it's not perfect, even if it has huge issues, it's miles better than having no threat model and not taking the time to sit down together and review them. So just get started already. And finally, your threat models are only ever as good as the actions taken as the result of the risk and vulnerabilities identified. So this whole thing is pretty much pointless if you're just going to as I said, let your diagram sit on a SharePoint or a Confluence page and never touch them, or if you're going to open tickets and let them rot in your backlog. So you do need to take action as a result of your threat modeling sessions. All right, then. I guess that was about it. Let's see if we have any question on the topic.
We had a question on the Discord chat. If you may, I can read it for you if you want.
Perfect. Yeah.
Okay, we have Dunn that was asking, what methods have you found work well to bring devs and implementation engineers to the table? He says that he finds that in most cases, they don't want to talk until they have a working product and that they want like a full threat risk assessment performed on. He adds that it seems like a chicken and egg situation. You can't do a TRA until there's an architecture, and you can't do an architecture until there's a TRA, then nobody is happy.
Absolutely, yes. So I think this is really a culture thing. I think depending on your specific environment, depending on your development team's culture, it might indeed be really, really hard to do. And I think at first you're going to get a lot more friction. This is something that you gotta slowly bring in and really make a case for it. Based on what I've just said, what I just presented, I think there is definitely a case to be made that threat modeling is super important. It's going to save you money and it's going to solve problems before you find them. And this is really the point that you need to drive home with your dev team and really foster that culture of threat modeling. So obviously, it's really not easy, and even for me, so this is something that we're really working on with our developers, and it's been working great. But there is still some friction in some smaller dev teams for the exact reasons that you're bringing up. So it's yeah.
Do we have any other questions?
Doesn't look like it.
We can end it on this. Just a quick reminder that we have the CTF ceremony coming up at 5 on the Track 2 YouTube channel, as well as the French Connection podcast coming up right after the ceremony. So I suggest you guys join up on that. It's going to be interesting. And they're going to announce the CTF winners and stuff. So go check that out. Thanks again, Samuel. That was really good. Really great talk.
Yeah, thanks, everyone.
Have a great end of the day.
Bye-bye.
Bye.